Welcome back, friends. If you already haven't checked out our previous videos in the Aptitude series, do make sure you check them out. We'll leave their links in the description as well as in the end screen. We decided to make a second part of the divisibility because there are certain numbers whose divisibility is never taught by any aptitude class, any workshop, and is neither there in any book. So we thought of bringing it out to you so that if you come across any such question in any aptitude test where these numbers are there, you can solve them easily and real fast and you don't get stuck. So firstly, we'll be doing it with divisibility of 7. Now for the divisibility of 7, there are two different approaches. In the type 1 approach, it is for numbers in the range from 1 to 999. And the type 2 approach is going to be for any number that is greater than 999. So it's really easy. But then aptitude classes actually teach you for numbers in the range from 1 to 999 only. They don't go beyond numbers greater than 999. So let's check out type 1. And the rule for it is, suppose you're given a number like 483. What we have to do is subtract 2 times the last digit from the rest. And if the resulting number is divisible by 7, then the number given is also divisible by 7. So as example, we have taken 483. Now, what we can see is that the last digit over here is 3. So, as per the rule, 48 minus 3 into 2, because our rule says subtract 2 times the last digit from the rest. Now, after taking out the last digit, the rest of the part remaining is 48. So, we have 48 minus 3 into 2, that is twice the last digit. So, what we have here is 48 minus 6, so we have 42. Now, as this number is divisible by 7, therefore this number is also divisible by 7. So that is how we find out for numbers in the range from 1 to 999. Now let's check out type 2, which is going to be for numbers greater than 999. Now, as I had said earlier, most aptitude classes and workshops, even if they teach you divisibility of 7, they'll teach you for numbers up to 999 only. Now what do you do if you have such a huge number and you have to check its divisibility by 7? So if you use the type 1 approach, let us see where it fails. We have this number over here, that is 1369851. Now using type 1 approach, we know that we take the last digit and we subtract twice the last digit from the rest of the part of the number. That is 13698 minus twice of the last digit, that is 1. So what you get is 13698 minus 2, which is going to give us 13698. Now we get this number. Now how do you check whether this number is divisible by 7 or not? Right, this is a huge number. This is where type 1 approach fails. Therefore we come to the type 2 approach, with which we can check for any number that is greater than 999 whether it is divisible by 7 or not. Now let's check that out. Now let us check what does the rule for the type 2 approach tells us. Now for any number greater than 999, we have to form an alternating sum of blocks of 3 digits from right to left. And after performing the sum, if the resultant number is divisible by 7, then the given number is divisible by 7. That is, firstly we will form an alternating sum of blocks of 3 digits from right to left. We'll perform the sum, we'll get a resultant number. Now that resultant number will be checked by using type 1. Now using type 1 approach, we will check whether that resultant number is divisible by 7 or not. If that resultant number is divisible by 7, then this number given over here is obviously divisible by 7. Now let's try it out. So let's check it out for the number 1369851. Now, forming blocks of 3 digits from right to left, we get this number, and this. Now we'll have to form an alternating sum, that is 851 minus 369 plus 1. So now do you understand what an alternating sum means? This is your first part. This is going to be positive. The second part is going to be negative, and again the third part is going to be positive. If we had a fourth part, that again would have been negative. So it goes that way. It's an alternating sum of 3 digits from right to left. Now we'll perform this operation, which is going to be 852 minus 369. Now it gives us 483. Now this is the resultant value that we have got. Let's check out, as mentioned in step 2, whether this number is divisible by 7 or not. For this we will apply approach 1, that is going to be 48 minus 3 into 2, as we'll subtract twice of the last digit from the rest of the part, that is 48 minus 6, which is 42. Now as 42 is divisible by 7, therefore this number is divisible by 7. So for any number greater than 999, we'll have to use two steps. Form an alternating sum of blocks of 3 digits from right to left, 1, 2, 3, any number of blocks, and then perform an alternating sum. What you get as the result, you have to check whether that number is divisible by 7 or not. Now to check that, we will use the type 1 approach. Using that approach, we found out that if it is divisible by 7, therefore this entire number is divisible by 7. It's that easy. Now let's check out for divisibility of 13. Now before checking out divisibility of 13, let us check out divisibility of 12. Now 12 is a number that is formed by the multiplication of two co-prime numbers, that is 3 and 4. Now what are co-prime numbers? Co-prime numbers are two numbers, those who have only one as the common factor. They don't have any other number as their common factor. 3 and 4 only have 1 as the common factor. Now 12 can also be written as 6 into 2, right? So the rule could have been like, if the number is divisible by 6 and by 2, it is divisible by 12, but it is not. Because 6 and 2 have common factor 2 as well as 1. It's not just 1, they also have a common factor 2. And co-prime numbers are the numbers that only have one common factor. Therefore, to check for divisibility of 12, we have to check it as a combination or multiplication of two co-prime numbers. Be it for any large number, be it for 24, be it for 26, be it for 22, be it for any large number. If you're given to check for divisibility of any large number, then always try to form them as combinations or multiplications of two co-prime numbers only. If you cannot form them as a combination of two co-prime numbers, then don't go for it. Now let's check out for the divisibility of 13. Now let's check out for the divisibility of 13. Now like 13, like 7, has two different approaches. One is going to be for numbers in the range from 1 to 999, and the type 2 approach is going to be for numbers that are greater than 999. Now the rule for type 1 approach is add 4 times the last digit to the rest of the number. If the result is divisible by 13, then the given number is divisible by 13. Let's try it out for 637. Now in 637, our last digit is 7. So as per the rule, we'll add 4 times the last digit to the rest of the number, that is 63, which gives us 28 plus 63, which is 91. Now if you don't remember the multiplication table, the rule suggests that the result should be divisible by 13, and then only this number is divisible by 13. Therefore, if this number is again divisible by 13, therefore this entire number is going to be divisible by 13. Now I'm just doing this in case you don't remember the multiplication tables. As 91 is actually 13 into 7. But if you don't remember the multiplication tables, you can check it like you have 91. In order to check if 91 is divisible by 13 or not, what you have to do is multiply 4 times 1 and add it to the rest of the number, that is going to be 13, which is actually going to be 4 plus 9, that's 13. Therefore, as 91 is divisible by 13, therefore 637 is divisible by 13. If you don't remember the multiplication table, then again apply this rule for type 1 and it will give you whether the resultant number is divisible by 13. Now if the resultant number is divisible by 13, therefore the number given is obviously divisible by 13. Now let's check out type 2, which is going to be for numbers greater than 999. Now to check for the divisibility of 13 for any number that is greater than 999, let us check out the rule. Now the rule says in step 1, we must form an alternating sum of blocks of 3 digits from right to left, as we did for divisibility of 7. And in step 2, if the resultant number is divisible by 13, then the given number is divisible by 13. Now, after forming an alternating sum, we will get a result. Now if that resultant number is divisible by 13, then the given number is going to be divisible by 13. Now how do we check if the resultant number is divisible by 13? For that, we will again go back to the type 1 approach. We will apply type 1 approach in step 2 to the resultant number, and if the resultant number is divisible by 13, then the given number is divisible by 13. Now let's check it out for the number 2911272. Here, forming the blocks of 3 digits from right to left, we have the first block, the second block, and the remaining part. Therefore, we will now form an alternating sum out of these 3 blocks, starting from right to left. From right to left. And now taking these 3 blocks from right to left, we have 272 minus 911 plus 2. This is going to be our alternating sum. Now, therefore, it is going to be 274 minus 911. Therefore, our result is 637 minus 637. Now, sometimes when performing an alternating sum, be it for divisibility of 7 or be it for divisibility of 13, you might get a negative number. Now, when you get a negative number like 637 or any negative number, just ignore this negative sign and take only the number. That is, take the absolute form of the number. Ignore the negative part and take the number only. So we'll take this number, that is 637. This is our resultant number. Now in step 2, it says that the resultant number, it should be divisible by 13, and then only this number is divisible by 13. Now 637, in order to check out, we'll apply, that is type number 1 approach, which is going to be 63 plus 4 into 7. As the type 1 approach says, get 4 times the last digit and add it to the rest of the number, which is going to be 63 plus 28, which is 91. And as I had said, 91 is divisible by 7. It is 13 into 7. Therefore, it is divisible by 7. Hence, this number is also divisible by 7. Right. Now, let's check out for divisibility of 14 and 15. Now, for divisibility of 14, if the number given is divisible by 7 and 2, then it is also divisible by 14. That's the rule. It is so because 7 and 2, both of them are co-prime numbers, and on multiplying them you get 14, as I had mentioned before. Now I am not going to show here any example because in this video we have shown divisibility of 7 and in the previous video we have shown a divisibility of 2. Now if you have to check for divisibility of 14, apply the divisibility rule of 7, apply the divisibility of rule of 2, and if the number satisfies both the rules, then it is divisible by 14. Similarly, for divisibility of 15, if the number is divisible by 3 and 5, then it is also divisible by 5. 3 and 5 are co-prime numbers, therefore multiplying you get 15. Check for co-prime only. Now, we have already shown divisibility of 3 and divisibility of 5 in our previous video. Apply those 2 rules to the number if you are asked to check for divisibility of 15. If both the rules are satisfied, then only the number is divisible by 15. Now let's check out divisibility of 16. Now let's check out for divisibility of 16. In the type 1 approach, we will check for numbers in the range from 1 to 999. In most aptitude classes or workshops, they will tell you that if you are given a number and you have to check for divisibility of 16, if the last 4 numbers are divisible by 16, then the number is divisible by 16. But what do you do if the number doesn't have 4 digits, if the number is only 3 digits? If the number is between the range 1 to 999, what do you do then? If you have a number like 176, how do you check if the number is actually divisible by 16 or not? You don't have 4 digits, so you cannot apply that. So here comes the rule. Add the last 2 digits to 4 times the rest. If the resultant number is divisible by 16, then the given number is divisible by 16. This rule applies for any number in the range from 1 to 999. Taking 416 as example, the last 2 digits are 16 and the remaining part is 4. So what we have to do is we will have to add the last 2 digits to 4 times the rest of the part, that is 4. That is 4. So it's going to be 16 plus 16, which is 32. As 32 is divisible by 16, therefore 416 is also divisible by 16. It's that easy to find out. So the only step is add the last 2 digits to the 4 times the rest of the part of the number. If the resultant number is divisible by 16, then the entire number is divisible by 16. Now let's check out for type 2, which gives us the ability to check for numbers greater than 999. Now let's check out for the divisibility of any number that is greater than 999. Now the rule goes like this, if the last 4 digits of the number are zeros, then the number is divisible by 16. For example, if you are given 10,000, the last 4 digits of the number are zeros, therefore this number is divisible by 16. Now let's check out step number 2, which tells us that if the last 4 digits of the number are not zeros, what we do then. Most aptitude classes and the workshops will tell you that if the last 4 digits of a number are divisible by 16, then the number is divisible by 16. Now how do you figure out if the last 4 digits of the number are divisible by 16 until and unless you memorize the multiplication table? This is how you do it. Now if the last 4 digits are not zeros, what you have to check is you have to check the thousands digit. If the thousands digit is even, check if the last 3 digits of the number are divisible by 16. That is, if you have a number like 2176, right? Here the thousands digit is even. Therefore, we have to check if the last 3 digits of the number are divisible by 16. For this, we apply type number 1 rule. So applying type 1 rule on the last 3 digits, that is 176, what we get is we have to add the last 2 digits plus 4 times the rest of the part of the number, that is 1, which is going to be 80. And as we all know, 80 is divisible by 16, as 16 into 5 gives us 80. Now if the number is given like 3408, where the thousands digit is not even and it is odd, if the thousands digit is odd, check if the last 3 digits of the number plus 8 is divisible by 16. So the number given is 3408, where our thousands digit is odd. So our last 3 digits is going to be 408. We'll add 8 to it, which is going to be 416, right? Now on this we'll apply type 1 rule and check if it is divisible by 16, which is we'll take the last 2 digits and we'll add it to 4 times the rest of the part of the number, that is 4 into 4, which is going to be 16 plus 16, that's 32. And 32 is divisible by 16, therefore 416 is divisible by 16, therefore 3408 is also divisible by 16. Okay, it's this easy. Therefore, if you're given any number that is greater than 999, you can always check for the divisibility of 16 using these 2 procedures. Now if you're supposed to find divisibility of 17, the rule is subtract the last 2 digits from twice the rest of the number. If the resultant number is divisible by 17, then the number given is divisible by 17. Now we're taking 2 numbers as examples, that is 221 and 4675. There is no other shortcut other than the one that I mentioned right now. So going by the rule, if a number is 221, the last 2 digits are going to be 21 and we will subtract it from twice the rest of the number. The rest of the number is 2, and so it's going to be 21 minus 4, which is 17. This is a resultant number. Now as this number is divisible by 17, therefore this number is also divisible by 17. In our second example, we have 4675. Again, we extract the last 2 digits, that is 75, and from it we subtract twice the rest of the part of the number, that is 46, into 2. Which is going to be minus 17. Now in any case, if you get a negative number, just ignore the negative part and check if the resultant number is divisible by 17. If it is divisible by 17, then the given number is also divisible by 17. Okay, that was for divisibility of 17. Now let's check out divisibility of 18. Now for divisibility of 18, if the number is divisible by 9 and 2, then it is also divisible by 18. Following the rule that 9 and 2 are co-primes, and by multiplying 9 and 2, we get 18. I'm not going to show any example, as in the previous video we have already done divisibility of 9 and divisibility of 2. So check them out, and if the number given satisfies both the divisibility of 9 and divisibility of 2, then the number is divisible by 18. Now let's check out for divisibility of 19. Now let's check out for divisibility of 19. Add 4 times the last 2 digits to the rest of the number. If the resultant number is divisible by 19, then the given number is divisible by 19. For example, let's take 6935. According to the rule, the last 2 digits are 35, that is 35. Now we'll do 4 times of 35, that is going to be 140. Here we will add this number to the rest of the number, that is 69. We'll add 140 plus 69, which is going to be 209. Now 209 is 19 into 11. If you don't remember the multiplication tables, then what you can do is you can again apply the same rule. That is, you take the last 2 digits, that is 09, you multiply it with 4, you get 36. You add it to the rest of the part of the number, that is 2, that is going to be 36 plus 2, that is 38. Now 38 obviously is divisible by 19, therefore 209 is divisible by 19, therefore 6935 again is divisible by 19. So if you have any resultant number after performing the operation according to the rule that you cannot make out if it is divisible by 19, then perform the same operation on it again as per the rule. If that number is divisible by 19, which gives you a shorter number, if that number is divisible by 19, then the resultant number is divisible by 19, and then the given number is divisible by 19. It's that easy. Now let's check out for our last number, that is divisibility of 20. Now let's check out for divisibility of 20. If the number is divisible by 10 and the 10th digit is even, then the number given is divisible by 20. Simply, here the number given is 480. So it is divisible by 10, as we all know, and the 10th digit is even. Therefore this number is divisible by 20. So we have covered every number from 1 to 20, including the part 1 and part 2 of the divisibility videos. So in these videos we have covered the divisibility of each and every number from 1 to 20. We did not skip any single number. So we hope that this is going to help you, and as these numbers are not touched upon by any aptitude series, any aptitude coaching or any aptitude workshop, we are sure that this video is going to give you an edge over the others in the aptitude tests. So thank you for watching and stay tuned for upcoming videos. Do subscribe to our YouTube channel if you already haven't, and do give it a thumbs up if you found this video helpful. Thank you.